All right, mathematicians, the goal of this video is to refresh our memory on sequences, series, and consecutive number problems. So you may have seen these in previous classes, or this may, I suppose, be new to you. As we go from left to right, we're trying to fill in the missing number in the sequence. And so when we go from left to right, we're adding 5 each time. And so add 5 and we get 18, add 5, and it does give us 23 as the next term. All right, this time we're adding 3, but then we'll add 6, and then we'll add 9, and so the next one we would add 12 to keep that pattern going of adding multiples of 3. All right, this next one is a famous sequence. You're going to add two terms together to get the next term. So you just start with two ones, and then you add those together to get the 2. And then we add a 1 and 2 together to get the 3, and then we add 2 and 3 together to get the 5. And so to find the next term, we'll add 3 and 5 together, and we get 8. This is called the Fibonacci sequence. It shows up a lot in nature, believe it or not. Lots of different instances where it will show up in nature. All right, next one, it looks like we're multiplying by 3. We would call that a geometric sequence. We're multiplying by 3 each time. So if we continue that pattern and do 27 times 3, we get 81. For the next term, it's a geometric sequence where we call that number 3 a common ratio. The reason we call it a common ratio is because if we divide by the previous term, we get that. So every time the ratio will simplify to 3 in this case. All right, on number 5, if we do 20 over 80, we get 1/4 as our common ratio. If we do 5 over 20, we get 1/4. So it is our common ratio. To find the next term, we're going to multiply by 1/4. Do 5 times 1/4. 5 is a fraction of 5 over 1, so we get 5 over 4. Sometimes you may see that as 1 1/4 or 1.25. Any of those is fine as far as I'm concerned for a short answer. All right, the next one. Notice we have alternating signs. That often happens when you multiply or divide by a negative. Let's see if we find the ratio there. It's -5. If we do -75 divided by +15, we also get -5. So our common ratio is -5. To find the next term, let's do -75 times -5. And we get +375. For the next term, notice that it continues on alternating signs, which often happens when we multiply or divide by a negative number. All right, this one, as we go from 4 to 8, we're multiplying by 2. Same thing from 8 to 16, we're multiplying by 2. From 16 to 32, we're multiplying by 2. If we go in the other direction, we'll divide by 2, and so we get +2 here. This one you might see as adding 3, then adding 5, then adding 7, and so we could add 9 and get 25. Another way to see this sequence is 1 squared, 2 squared, 3 squared, 4 squared, so the next one is 5 squared, which happens to be 25. All right, on this next one, you can see it as subtracting 7, or you could say adding a -7. It is an arithmetic sequence where the common difference is -7. So when you do -16 minus 7, you get -23 for our next term. Again, that -7 is common difference. The reason we call it a common difference is because we can take a term and subtract the previous term, and we always get that value. All right, two consecutive numbers whose sum is 27. Well, x will represent the first number, and then the next number we could call x plus 1. Consecutive meaning right after that. So some number, and then some other number, x plus 1, the very next number, and their sum is 27. So let's add those together and set it equal to 27. Combine those like terms. X plus x is 2x. Now we have a two-step equation. To get rid of that adding 1, we'll subtract 1, and we get 2x equal to 26. To get rid of multiplying by 2, we'll divide by 2. So x is 13. So our first number is 13. The sum of the two numbers is 27. Will the next number be 13 plus 1, or 14? And we can verify that 13 and 14 do in fact add up to 27. So our two numbers are 13 and 14. Alright, this time we're told two consecutive numbers have a product of 120. Some people may be able to just think through numbers that multiply to get 120 and see that 10 times 12 is 120. And so 10 and 12 are the consecutive even numbers. If you don't know that or didn't pick up on that, another way to attack it is to say, okay, x is going to represent my smallest even number. The next even number would be x plus 2. So you could multiply those, set it equal to 120, and solve. You would have to solve that quadratic equation. After you distribute, you might get it in standard form and factor or quadratic formula, or complete the square. So any of those would be ways of solving that. All right, 12. What is the sum of the first 5 terms of an arithmetic sequence with the first term of 9? My first term is 9. The common difference is 3, so we're going to add 3, and we'll have 12 as the next term. If we add 3, we'll have 15 as the next term. And then add 3, and 18 is our fourth term. Add 3 again, and our fifth term is 21. So we have those first 5 terms now. We can add them all together. Well, 9 plus 21 is 30. 12 plus 18 is 30. 30 plus 30 is 60, plus 15 is 75. Sum of the first 5 terms is 75. You may have some fancy equation that you've memorized for that. You're welcome to use that. But I think for a manageable number of terms, then it's easy enough to just build the sequence that far. All right, 13, 3 consecutive odd numbers that have a sum of 45. So let's let x represent our smallest odd number. X plus 2 would be the second odd number. X plus 2 plus 2, or x plus 4, would be the third odd number. And they have a sum of 45. Sum means add. So now let's add up all those like terms. X plus x plus x is 3x. 2 plus 4 gives us 6. Now we have a two-step equation. To get rid of plus 6, we'll subtract 6. We have 3x equals 39. To get rid of multiplying by 3, divide by 3. And x is 13. So the smallest number is 13. The next odd number would be 13 plus 2, or 15. And then the last odd number would be 13 plus 4, or 17. So these are the 3 odd numbers, consecutive odd numbers, whose sum is 45. You can add them all up and make sure that it equals 45. Now there are some equations you can use for this stuff. So like we could let a sub n be some term in an arithmetic sequence where a sub 1 is the first term and d is your common difference. So let's suppose we have a first term of 7. And let's suppose our common difference is negative 3. Well, what if we wanted to find the 10th term of the sequence? Well, let's replace n with 10. So we'd have a sub 10, the 10th term of the sequence, equals the first term of the sequence, plus n is the 10 now, minus 1 times the common difference, which happens to be negative 3. And now we're just simplifying the right side of this equation. And 10 minus 1 is 9. And then we'll have 9 times negative 3, which would be negative 27. Negative 27 plus 7 would give us negative 20 for the 10th term. If you're not sure, you can build the sequence. We've got 7 as our first term. and then we're going to add -7, add -3, or you could think of it as subtracting 3. So our next term, second term would be 4, third term would be 1, then -2, then -5, then -8, then -11, -14, -17, and finally -20. N values here are first term, second term, third term, fourth term, fifth term, sixth term, 17th, 8th term, 9th term, and 10th term. So just verifying that we did all that correctly. So if you want to, you may want to memorize that equation. They may or may not give it to you on the ACT. Same type of thing for geometric sequence. Let's suppose our first term of this geometric sequence is 10. Let's suppose our common ratio is 2. And let's suppose we're trying to find the 9th term. Well, we'd replace n with 9. So a sub 9 equals a sub 1, which is 10, times the common ratio, which is 2. We're trying to find the 9th term. So replace n with 9. So the 9th term is equal to 10 times 2 to the 8th power. 2 to the 8th power, that's 2 times 2, that's 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. And then we'll multiply that by 10, and so our 9th term of the sequence is 2,560. So that's how you can use the equation for the geometric sequence just to find a specific term without having to build the whole sequence. All right, so hopefully that's helping you as you refresh your memory for the ACT exam.